My name is Ala. I'm a PhD student at Performance Augmentation Lab at Oxford University. The first lecture will be about perception, storytelling, and design. First of all, we want to understand how our body and how we humans work and interact with that technology. Why this is important to understand, because that's all the underlying principles that we will have for the rest of the course. We will start with perception, then design, storytelling, and the summary of basically the wrap-up of this course. Okay, let's start. So we are living in the physical world with all the people walking around, and every minute we receive all sort of the stimuli from the outside world. Like someone is talking to us, we have the bright light and we're reacting to that, we have a really weird sound coming from somewhere, and we're constantly paying attention to different stimuli. The first part is our vision, and we will talk about the vision. But we have more senses: vision, hearing, touch, taste, and smell. As you can see from this graph, vision is like the most powerful sense that we have, because 30% of the brain neurons that we have are dedicated to vision. Then it's touch, hearing, taste, and smell, not so well. But basically, vision is the most important way we interact with the world. Basically, the vision starts from sensation. When we receive stimuli from the outside world, we sense them. It's basically the bottom-up process. When we receive something from the world, we top it up to the brain, and basically we have the stimuli. They're still processing. They are in our brain. And then we have the perception, basically how we perceive and how we analyze this, how we interpret this stimuli. That's basically the perception, how our brain interprets all the signals that are coming from these senses to our brain. And perception consists from three main processes called recognition, recognizing, organizing, and interpreting. Basically, recognition happens basically every day, every second. We are aware of everything that are around us, like different sounds, different lights. You know the colors of the chairs that you're sitting on. You're hearing my voice from this corner of the room. You're paying attention to this area. If someone would knock to the door, you will pay attention, and your attention shift to that area of the room. You're recognizing what's happening, basically. Then you're organizing everything that you perceive. You're organizing them to, I don't know, smells in one group. You're organizing your vision stimuli. Maybe something is very bright for you, and you want to move your head to the different side because it's too bright for you, for your eyes. You're too sensitive. And then interpreting, basically understanding what that means. The basic example is the light switch. So when you're standing in a pedestrian cross, you're trying to interpret what light means for you. The red is a sign that you need to stop, and the green is the light that you need basically to go. And our universe and the world, the way it organized, it has all this sort of predefined, classified stimuli that we are trying to understand in our everyday life. And that all sort of gathers together into sensory information about our world, sensory information of what we perceive. We start to understand with how the human eye works. It's just a basic biology, just to recall some of the main aspects. So probably the quickest example to understand how it works is just to imagine how the camera works. You know that light is coming from outside to the lens, it switches, and it goes to the processing unit in the camera. In our case, it's our brain. So perception is the product of vision. When we see something, then we interpret it. And I really like this scientist called Alvanoy. He wrote a lot of books about perception and the way perception is tricked and misguided and misinterpreted by us. And perception is not something that happens to us. It's something that we do and we choose to do by our own, I don't know, experience, habit, our childhood habits, everything that happens to us, that happened to us in the past. And it's like a gathering of all the sensomotory stimuli that we had. And for example, in my experience, I would interpret red color as something bad. And maybe in different countries, people will say that, oh no, this sound means something nice for me, but in other countries it doesn't, because it's just a different experience. And this is just a nice graph of how people from different sides see the different perceptual illusions. So you can't really say how many blocks are there, because from the different sides they're different. So there is no like one answer of what perception is, because it's not universal, it's unique for every person in this room as well. But it's not unique in this way, because everything that we see starts with the light, because there is a visible spectrum of the waves that we see. And I really love the way Greeks formed the word light, because, for example, the word fantasia, like to fantasize, fantasy, comes with this prefix phant, phos, which is light. And without the light, we can't see, so we can't imagine, we can't dream, we can't understand. And light is something really basic that shows us what's happening. If you close your eyes, you don't see anything. That's without the light. And there are two waves. We have long waves and we have short waves. They are blue. And that's how sort of the light transforms into meaningful information for us, starting from the short and long waves across the different parts of the visible spectrum. And so when the light source is working from outside, it comes to your eye. Basically, it passes through the cornea and goes down to the iris. The light reflects, and sort of vision at some point is also a chemical reaction, because you have all this rod and cone cells at the back of the eye. And we can't really only say that, okay, it's a chemical reaction, but different eyes are different. I'm, for example, super short-sighted, and I wouldn't be able to see any one of you without my lenses, for example. And this is just a basic example of how our vision is transformed by external means. Let's just have the quick example, a quick exercise of how we see. I would like you to close one eye, left to right, as you prefer, and put your finger on top of your eyes if you can. Just try to do it. Yeah, it's really nice. You will experience some nice sensations on the next slide. If you can do this, and then try to look at the different parts of this picture. Try to see on this side, try to look at this dog, and try to explore some different images on the walls, and you will see how your eyes moves in really nice and small, tiny movements called saccades, saccadic movements of the eyes. And we don't just stare at one point in the picture, even though it's not really big, it's not the size of the wall, but we're still trying to explore different aspects of the painting, but the eyes is moving. So it's constantly moving, and we experience our vision by just doing this saccades movements. This is also part of the method called eye tracking. Probably you have heard about this. It's the method where people are trying to track the movements of the eye to understand how people experience things. This is, for example, the example from the National Gallery in London. People were trying to understand how users, gallery visitors are experiencing this picture. So what are the hot areas? So they're not really looking at this area at all. So the action space is happening just in the middle of the image. And it's always for them a solution, maybe how to structure exhibition, how to structure a working area, how to make people understand the art more better, and also understand why particular features of the paintings are attractive to users at the end. Also, our vision helps us to understand some of the distinctive features of the environment. Maybe you just looked at this tiny man in the blue jeans because it was distinct from everything on the background. So we have some of the particular features of the environment attract us, like really bright colors, or, for example, moving objects, like in this image. So you just looked at that animated GIF because it's moving, but not because you liked it. And this is how the eye works. It constantly focuses on something moving, and the image is frozen on the back of the retina. because that's just how it works. And if I will just move to this side of the room, you will look at me because I'm walking. But if you're not just looking at your mobile phone, for example. Another way the perception works is by understanding some undistinct features. We can call it pattern recognition, but try to recall this painting. Do you know who did this painting? Yeah, nice. That famous guy. Yeah, and we just didn't know who that was, but we had a previous experience before of understanding the particular colors, shapes, and that's how we recognize things. So it hasn't to be very distinct in terms of the way you depict it. We can have a blurred background, but we still will be able to recognize some of the elements and recall our memories about them. And in designing, when you're designing something, for example, for your, I don't know, classmates from the past, you might want to recall things that you did with them during the last 5 years, and based on that, without telling them about this, just saying some distinct features and blurred, I don't know, memories, they will still remember that because they have this image on the back of the brain. There are principles and laws of how you perceive things. There are 3 groups, and we will go through them in a second. So first one is figure a ground. So it's the distinction of the elements. So without explicitly saying people and pointing people towards the idea what's on the image, you can see and recognize what's on it, whether there are on the left side 2 people looking at each other, or it's just a vase. Or I really love the last one with a penguin slash human. It's like a haircut, but it's still a penguin. I'm not sure whether you can see, but it's just here it's like penguin's eye. If you sort of switch your attention, you will be able to recognize the person's head. These are also some of the examples of how you switch your perception between the background and the foreground. So you can you can't see really 2 of them at the same time, so you're constantly switching between paying attention to either one or another. It's the figuring ground perception principle. Another one called similarity. It's the way group of objects belong together. Even they're not directly together, we perceive them as they are together. For example, the black circles, we see them as 3 groups of black circles, but all of them are located on an equal distance between one another. The last one is just a random triangles positioned in the space, but we think that this is a sun and an eagle, like a symbol of a company. The principles of proximity. We perceive the distances between different objects, and we also try to group them if they're near one another. We group them horizontally, vertically, and that image on the right is an example of how we can group just a number of dots in the portrait of a person. I think it's a German exhibition poster. It's very distinctive, but they're just located in this way, but we think that they belong to one group. The principle of common fate. So if the objects are facing one direction, we perceive them as they're grouped together. The one on the left side, so we have all these arrows. And personally, myself, I see constantly all the arrows pointing to the northeast, because for me they're grouped together and you distinct them, as well as the orientation of the birds on the right. The next one is principle of continuity. I think it's used in modern art a lot, where people just draw some lines and they understand that, oh, okay, that's the shape, that's an object, and they can try to recall maybe a flower, a tulip, or there are a number of these examples, like you can draw a portrait using just one line, or understand the figure, and you also understand the direction of these lines as well. because somehow unintentionally you try to connect all the missing lines in your brain by yourself. The next principle is the principle of closure. So when the objects are located together, but there still are some missing components, we try to fill in them automatically by ourselves without actually having them on the image. For example, here we can see a cube, just the lines of a cube, but it's not here. And most people see the two triangles here, the one just in white colors, because they somehow see it just from having these edges cut from the circles. That's also how some companies use to design their logos or something else, like the magazines, where missing parts are filled in automatically by our perception. The next principle is the principle of area. Basically, this is the nice thing, because people think that these blue circles, they are in different size, so they're different in terms of their size, but actually they're equal, but because we have the different background, or sometimes when objects interfere with different colors, shapes, we think that they're different in size. It's just the principle of how we use the surrounding environment of an object to determine its perception. Principle of symmetry. We tend to perceive objects as symmetrical, and we also try to look at objects as symmetrical when they belong together. So this is one of the, I really like this symmetrical example of the Bike Expo in New York, when they try to look at both sides of an object, but we still see it as a whole, and we imaginally cover the second half of an object for ourselves. But even though we have all these nice principles, which seems to be very organized, sometimes when we use the technology, when we try to interact with some glasses and devices to perceive the world around us, we might have some problems to sort of perform that. One of the most, like the biggest problem with augmented reality glasses and perception is vergence accommodation conflict. It's very complicated word, but I found this image, and I think that explains it from the best angle. Basically, when we look at the distance, we focus on one point, so we have one focal point at the end. And the simplest example is we have an object closer to our eye, so we focus on this one, and then we wait a couple of seconds and we look somewhere on the background, for example, on the door. And the way my eyes, they accommodate, so my focus accommodates to different objects, takes like a little half of a second, less than a second, so we don't really notice it. But when we try to do that and perform that using the technology, so using the screen, so when we have display, we have different focal distance. So we're trying to focus on this point in the room, but we are looking at the display, and our eyes think that, okay, that's the point, I need to focus on this area. But that's not true, because focal distance is different from the focal distance in the real world when we are not using the technology. And our eyes, they constantly experience vergence and accommodation conflict between looking at the display and looking at the point where we want to sort of aim the finish line of our perception. And since it's something that quite annoying, when you're using AR, it might cause a headache, it might cause eye strain, and people are just not used to that. There are a number of principles how we can design our technology to make it affordable, to make it less painful for us to experience. First of all, we will try to use long distances. So when we have augmented reality experience, we have all our holograms, we will try to position everything as far as possible to make sense of it. So we are not switching the distance between holograms, so we're not making a person feel uncomfortable by constantly switching the attention. Second one is the focal distance. So we need to simulate the distance in the display and the focal distance. That means that when you try to equalize and position your holograms, try to make them stay at the same point as long as possible, so we are not switching our attention rapidly. The third one, move objects in and out of depths at a pace that gives the user's eye more time to adjust. That interferes with the second one. So when we're working with our holograms, where we're working with the content, we are trying to make that as comfortable as possible. We are not making really rapid movements from one point to another. We're trying to make it as smooth as possible, because the time requires for you to adapt your distance using AR glasses is much longer. Not like you need to wait 5 minutes, but it's like just a matter of seconds, but it still matters for people. And the last one, maximize the reliability of other depth cues. It's the fact of if there are people from visual effects, so you know how you shade things on the background to make something stand out. You might want to create depth cues as realistic as possible, using some shadings to the holograms, editing them so they look more 3D, and our brain think, oh, okay, that's something more realistic. Which is, it sounds like it's really hard to achieve, but it all sums up to the fact that you basically try to follow and mimic the real world as much as possible in your design. Don't try to create a sci-fi movie from 70s where everything is like super random, because that will make people feel uncomfortable based on the fact of this VAC, vergence accommodation conflict. The next point is about the depth layers. It's really something natural for us to focus on different points in the room, on different background layers. But when you're designing something, try to think about your content in a multi-leveled way. For example, you have something really important happening on the foreground. Usually it's within 1.5 meters in front of you. And you have something not so relative happening on the background. It's up to 3 meters. And when you're designing your content, for example, or your story, you're thinking, okay, how I will position the elements, the holograms for my experience. And you think about their timeline, for example, what's happening when. Whether people will look at that point in the room, whether they will focus on the foreground or on the background. How do I achieve the comfortable line, the comfortable state of interaction with the technology? Think about that as layers, because it's not focused on the one screen anymore. It's 3D, and you need to think in 3D when designing for that. And also think about the VAC, because don't really move things rapidly. It will create some uncomfortable situations for the user. Okay, that's all about the eyes. Some more bits about the hearing. So the device that we're currently working with, Microsoft HoloLens, it has the magical option and AR as well as the spatial sound. So it's like the sound in 3D. You probably went to the standard and modern cinemas where we have all the 3D sound, and the sound is moving from one point to another. And AR is perfect for that, because it's trying to mimic that effect, to mimic the effect of the real world at the source of the sound. We also, as humans, pay attention to the source of the sound. That's absolutely natural for us. For example, if I just clap, you will pay attention to that, because you have sort of an irritation, something that is happening, and it doesn't really look nice for you, so you're paying attention to that. It's not always an unpleasant experience, but it's just the fact that you're always paying attention to something that is happening in the room. There is a magical theory. It's called signal detection theory. It basically sums up as the process where people pay attention to something that matters for them, something that people think it's relevant to their experience, something that they like. When you listen to a person and for some reason you feel like, okay, I don't like how it sounds, you won't listen to that. But in a more advanced matter, we listen to something that matters for us personally. And an example for that is just the perfect example for a lot of like families probably. The parents, for example, the parents, they are trained to listen the sound of their babies, like the crying babies. They always on, they always alerted, so they need to help them, they need to take care of them. And some researchers, they did a study where they tried to understand how parents would react to different distractions. Just an example, they didn't pay attention to a train passing by, so they didn't really hear that because they were so focused. Their hearing was so focused on listening to the babies crying because they need to protect them, feed them, and etc. etc. And it's just a personal choice. So our hearing is also adjusted by our preferences, by our personal, probably, perceptions of something that is valuable for us. The third component is the touch. We experience our world with that sense as well because we touch things every day, a lot of things. And one of the aspects of the touch is proprioception. Proprioception is basically the perception of the world with our body, so how we perceive things and understand things around us. A basic example is, imagine you are staying in the room, in this room, and you try to understand, okay, where is the exit from this building? Where is the toilet in this building? And you will draw like a random visualized path, and you will see, oh, okay, it's something on the left and then on the back. The exit is on the right. Okay, the teacher is standing in the room, and if you want to go out, the door is here. So our body experiences all directions of the environment. We understand this space in 3D. And when we see something, it's like an intention. When we see something that we need to grab, we will understand its shape. For example, the material, something is really soft and something is hot. And the basic example, when you were really small, your family, they tell you, oh, please don't touch because it's hot, like an iron or a kettle in the kitchen. And you understand, when you look at something, you understand, oh, okay, I won't touch it because it's really hot. And imagine a scenario in the augmented reality where there's like the shooter with fireballs. And probably in this case, you will try to avoid them because you think, oh, okay, that's something with fire, that's hot. I don't want to touch it with my body because I might experience something unpleasant. And that comes from the proprioception of this sense that we have. Okay, that sort of sums up quickly the perception, and the next component is user interface. I think this part is really important because with this technology we are making a big switch from the classical way we used to interact with things, from interacting with a 2D screen with the computer, and I wanted to dedicate this part of the lecture to the UI of the technology. This is just a quick recap and look at why user interface and user experience are different. A lot of people, they think that, oh, okay, UI, UX is like the same thing, but it's not. Why we have two of them? What is different? So user interface is basically all visual that you see. It's colors, the design, the position, the shape of the website, the layout, the typography, the color palette. So everything visual that you see from the object, from the website, from the computer, from the game, from your phone, that's how you interact. So it's like everything that's visual to you. User experience, it's all below user interface. It's something that makes you interact with that technology. It's interaction design. It's the way system is built. It's the way that research is done for users, and the developers, they understand the needs of the user. It's a scenario of how you will interact with that website, for example, or with the game. So just basically, these are actions, and these are visual consequences of these actions that you experience using the system. And today is about UI, this part at least. So we lived like for a really, really long time in this like 2D world, and considering the time frame, it's a really tremendous switch, because like 30 years and we have something really outstanding in our hands that we have, like everyone has a phone. And we're used to that. We're used to all this like references, what the camera means, all these icons. It's absolutely similar to us. We're literate to use that in our everyday life. But now the technology has changed, and we think, okay, that's probably not okay. We have all these magical senses that I was talking about before, the vision, the touch, the sense, the proprioception. Why we are not using them? So why? And exactly augmented reality comes to that point, to use all the senses, to move away from the 2D screens. But thoughts about that, they came a long time ago. In the 60s, the person called Douglas Engelbart, he invented the modern mouse. But the aspect of that was not to invent something that we will constantly use. It was about inventing something that would augment human intelligence, that would help us to experience our world in more senses. It doesn't mean that he thought, okay, mouse, and that's it, that's the point. He wrote a lot of articles about augmenting human intelligence in using all the senses that we have, using our bodies, our speech to work with technology, but not to work technology, to use technology to use our senses. It's just the other way around. And he was the thinker who started that line of thought. And then in the 1968, the Ivan Sutherland, the very famous, probably the founder of VR, mixed reality, he said this phrase: if the task of the ordinary display is to serve as a looking glass into the mathematical wonderland constructed in computer memory, it should serve as many senses as possible. So even though he had this like really weird thing on his eyes, he was thinking ahead of, and now we have it, like after like 50, 60 years, we have this technology now. It's not like super advanced, but it is very advanced compared to what we have. And we're only starting to, we're at the beginning of this shift. And we need to think spatially, centrally about our experiences that we build, not in terms of just 2D screens and layouts of the phones. In terms of the spatial holograms and spatial interactions, in terms of having something tangible maybe, something really realistic that we can work with. And all the things that surround us, they have their affordances, they embody the way of thinking. For example, when you see something that you don't like, you might just want to throw it away. Or when you see a fruit, you want to eat it, because each object in our world has its own reasons, functions, and aims. And with the same, as we have like a drag and drop gesture on the phone when we drag something to the bin, we have the same action in the physical world, just deleting, resizing, changing shapes. And augmented reality is about mimicking real world, but not creating new sort of unimaginable references. I mentioned the affordances. Affordances are the possible actions. Donald Norman, he invented this term, and he created the notion of affordances. That basically means that objects represent their functions. 3D world. And this is an example of how the menu can work in augmented reality. It has some really distinct features from what you used to have. For example, a person here is wearing the glasses, and this is a display, like the main screen, and it physically follows the user when he's walking. Or the information can be locked in the world, but we still know, okay, this is the information point, this is the display, I will interact with it just in a second. Or we have mixed user interface, that is world locked and world unlocked. Basically the interface that tells you where to go, tells you the functions of what you need to do, and the interface that talks to you using the affordances that I mentioned before. It's just an interface in the shape of the pointer, like the navigational interface, but we don't see that as the classical interface, because it has a different affordances in it. It's really another way how we need to think about user interface in augmented reality is still biological, the natural field of view. So where to position things, for example, in the system. The natural field of view of the human is about 140 degrees, but with the peripheral visual is 200 to 120. Compared to the peripheral vision of the body, it's still very, very different, but we need to consider that when we design for AR. We don't just position elements somewhere randomly in the room. We need to follow the natural ways of perception. Don't put something on the back when there is no sense for that. If you can't direct people to look somewhere in the room, there will be no sense of positioning something there. So at this point, we are still referencing our limited, unfortunately, or maybe happily, field of view. And since we're limited at some point, but we are not, we need to follow some of the rules that how we can work with the system. For example, do you know the Maslow hierarchy of needs? That's like very something standard that we all know, like safety, food, we need to sleep. This is something similar, but in AR. So first of all, is the comfort, is ergonomics of the device. Would you use that technology at all or not? Would you want to have this thing on your head, whether it's heavy or not? You will choose that. And as soon as the system or technology passes this level, it goes to the design. Something that we are talking about right now. Does the UI environment make sense? Do we understand how to use that? Do we understand what that means to us? The next level is the content. It's basically probably one of the most important things. Do I get the value from the system? What does it give me as the user? How can I benefit from using that system? Probably that can be applied to your mobile phones as well, to different applications. But the difference is sometimes people don't think about ergonomics at all. Some mobile phones are not so useful, but when we think about augmented reality, this point is very, very important because that's something that we need to have. You can't interact with your phone when it's lying on your table. You don't need to hold it, but with augmented reality, you need to fulfill all the levels and go back to the top. Do I want to come back and use that system again? That's the most important question, because many applications in the augmented reality are like single-use applications. You might experience today like holoanatomy, biology, holoheart is like hologram of the heart, hologram of the planet, like galaxy explorer, but that's just a single-use applications. You use it and what? It doesn't have a consequence. You don't have a value from using that system. When you're thinking about designing something, when you will think about your ideas for your projects, try to think about that. Do you want to come back to that system and use it again? Do you have this value? Is it a single-use application or it's a multiple-use application? How would I use that? So please try to think about this every single time, about this question when you're designing something. Your product, your ideas, it's basically everything in your life comes to that question. So do I have value, do I get value, or do I give value to someone? The next one is the component of augmented reality. It's called immersion and exploration. We talked briefly about that the system is absolutely different to what we had before. We don't have just mobile phone. It's the environment that activates all the senses that we have. So user is centered to the system. So imagine like you're working with your computer, Windows or iOS system, and okay, this system is working and I'm working with this system. With augmented reality, you are an operating system of this technology. You're using the functions of that to work with them, to create them, to modify them based on your rules. And the user is center of this environment because augmented reality is the most user-centric system that's been developed today. try to think about the next one. User will want to try their own ideas. When you create something like a system or user interface, and you will think that the user will follow your scenario, like step 1, open it, close it, but how that works for someone else in the room. Is it very logical for a user to go this step as a next step, or it's not? So try to think about all possible ways of how your colleagues, friends, and users will interact with that technology. What is the next step? The third one is a scale makes a huge impact on present. Since this environment tries to mimic everything that is real, so realistic aspects, we need to think about the scale of this experience. Is it a room scale experience where we have sort of one-to-one size, very realistic and real, or is it just a mock-up or a demo or a map of something that you put as a hologram on your desk? Try to think about the first question. What is the value of the system? And then try to think about what scale do I need to do? Do I need to immerse user, for example, as fear fighters? When someone is scared of flying, you create this VR application where you mimic the airplane, the clouds, everything. It's like full immersion. But maybe it's not something that you would want to create for another experience, like, I don't even know, like a classroom. Maybe for a classroom experience, you would want something else when you train someone to do that. And the last one, small details matter. That's always like the point, because people pay attention to all the tiny things in your application, like size of the elements. We will talk about that later. But small details like gratification. What do I get from this application? Do I have the confirmation of that value that I've got from the system? Maybe if you're designing something very specialized to a company or to your university, whoever you're designing for, maybe there is something that the user wants to see in this, something that matters for corporation or for university. The next principle is attention. You will need to cope with that. You have that with the users. They will have freedom to do anything that they want with the system. And if you want them to experience your application in the way you want, you need to guide their attention. You need to create some unimaginable and imaginable ways of forwarding that attention back to the system, back to your holograms, to your interactions. And it's very important, and it's really hard to lose. Because the space is completely open for the exploration. It's absolutely 3D. The user can walk wherever he wants and look wherever he wants, but it's really hard to sort of get that attention back. And okay, here is my system. I want you to work with that system in the way I want. And for that, we have numbers of tools that we can use. We can use different pointers, highlighters, different navigational system in the application of how to get this attention back. But when you think about your scenario, try to always understand that, oh, okay, I could lose that attention at all. How can I get that back? And audio and visual cues help us to get that back, but it's not. It's really hard to find the balance between audio and visual cues in the system, but it just depends on your application. And forced attention, it's not a good idea at all. So don't try to create some absolutely realistic sounds or dramatic navigational pointers, because it really will be hard to follow them at the end. With the HoloLens technology, we have replications of our senses, sort of extensions of tools that are represented as the functions. We can use our gaze, basically our vision, as the way we see things around. We use the gaze cursor as the metaphor of the mouse cursor on the computer, because since we're working on the HoloLens, I'm not going to cover in this lecture all possible inputs with all augmented reality devices, but there are set of standard interaction methods and interaction inputs that are across all the devices. For example, there is only one that has the eye tracking. It's released for the public, not for the research use. Magically, they have the eye tracking system for navigation of the content, manipulation of the content. HoloLens doesn't have that, but it has the gaze cursor as the pointer, so sort of I'm looking at that location in the room. Also, with the HoloLens, you can use your voice to activate different things, like using voice commands. You can use spatial audio. As I mentioned, this 3D immersion audio and immersion sound to also guide people, to sort of show them how sounds move, where something is located by positioning 3D sound in different places, and also gestures. Just a brief example. This is, for example, a standard setup of how we can use our gaze. We're in the morning in the kitchen, we have this weather forecast, and we want to cook something, and we want to trigger these holograms just by looking at them, using our gaze and gestures to activate them. It works like this. So we have the gaze cursor. Imagine like an array is coming from the device and it's facing the target object. So we draw this like imaginable line coming from the device, and that represents the way you're looking in the space. Something like this. So you're basically ray casting the point. It's not visual, so this ray is transparent. You can also create it visible, very, very visible in terms of the color, but normally it's just a representation of the final position of your gaze at the target point. Usually it's like the highlighting area on the surface, and it comes as a standard cursor in the mixed reality SDK. Also, we can use our voice commands. For example, you want to create a hands-free experience. What would you do? You probably would want to use some voice commands to work with the system. Imagine someone doing the maintenance procedure, hands are busy with some tools, and it's really hard to go to the next step with your training system. And voice command is the best option in this case. It might not be available for everyone, because we could have deaf people who can't speak, but in this case you need to explore for whom you are designing, who are your users, and maybe create some new input methods for this case. Spatial audio is that magical 3D sound that we have with the HoloLens. It works really nicely because you have like an imaginable clouds of sound around your head, like in a bubble, and it can guide your direction. For example, when something is happening on the back, I will have sound coming from that area, from my back, and I will naturally move my body to see what's happening in this area. So we can use 3D sound as the basic example of navigation in the environment, for example, where we want to move people to look somewhere or to go somewhere. And also it has a really nice sense of immersion if you want to create, I don't know, relaxing environment for the person to listen to some area. And at the same time, it's not really distracting because the way it works, it doesn't interfere with the sounds of other people. So you won't be able to hear what other person is doing in the room. Gesture is probably, for personally, it's really not very comfortable way of interacting with that technology, at least the gestures that are now available for the system. The standard click gesture represents the click of the mouse. It's really hard to perform. I've been working with that for 2.5 years, and I have some problems with my wrist because I'm constantly doing that when I'm testing something. It's not really comfortable because everyone is different biologically, and for some people it's really hard to bend these 3 fingers to create this position for the click gesture. But technology is developing, and don't lock your minds on thinking, oh, okay, that's not comfortable because it's not comfortable for people, I don't want to use it. Try to use it, try to create new gestures if you want, try to experiment and accommodate, because it's natural for people to use gestures even when they speak, when they talk to each other, when they go to the supermarket. They're always using their hands in different ways. Basically, it's the main way of interacting nowadays with that technology. Also, other inputs like, for example, clicker and laser pointer. For example, with the HoloLens, we have the tiny, like a remote controller. It's like a button, and you can use that to click if you don't want to use your gestures. But when you're designing something, these are the more like 4 main concerns about the input methods. Ergonomics is whether that will be that gesture and that input method will be appropriate for the environment. As I mentioned before, you are in a factory, your hands are doing something, you are busy. Use voice commands, use something else, use eye tracking. Don't use your hand gestures. Safety guidelines for the content, it's about the appropriateness of that gesture in the particular environment. Imagine you're somewhere wearing gloves, we're working with chemicals in the chemistry lab, and you won't be able to remove your gloves to do something because the device might not recognize your gesture. So think about other alternative input methods. Clicker, I mentioned, is as an additional way of using that technology. It's not always comfortable, but some people just like it because they don't want to speak. They don't feel comfortable speaking in some environments, for example, quiet environments. They feel, I don't know, shy. They don't want to express themselves or talk to the system, so they want to use clicker, for example, or the hands instead of the voice. So make your system available to the variety of inputs. That's sort of the summary, but also try to adapt them to the environment that you're building. Yeah, and other people on their voice commands, they just don't want to talk, for example. What's next? How the people will use your system if they don't want to talk to that? Text as the next point. So we've talked about the input modes where we can use our hands, our voice, different clickers. What is on visually is the next question. Okay, text is not so good because it's really hard to read. It's absolutely impossible to predict the right size. People are different, and even on the slide, it's really difficult to read the text. You just want to have some visuals, you want to listen to presenter, you don't want to read because it's boring for you. And if AI offers you such a great things as holograms, different magical things that you can create, try to use text as little as possible. Maybe at some point text is important when you really want someone to understand, it's like unifyingly understand. For example, if person is interpreting colors differently, or we have people coming from different backgrounds that can't really understand what that hologram mean. So try to use the text in this case, because English, for example, is like super unified language, and you will be able to, like, you will be 100% sure that that sentence or that instruction will be readable for everyone. But also think about the size of your text. There are a lot of type editing systems for HoloLens. There was even one researcher dedicated his career to creating augmented reality fonts. And he's pretty good at that because he created some, like how the fonts can change their shape based on the shapes of the physical objects in the room. So if you really need to work with text, try to use that toolkit, because that would really help you to make that text readable, visible, and it will make sense. Aspect of colors. It's really hard to achieve the super realistic color experience at the end. For example, you want to have a really nice color palette, but the way you will get it at the end is absolutely different and not predictable, and that depends on many factors as lighting in the room, I don't know, shape of the objects and color of the objects in the room, their material, and the way they will reflect light from these objects. And that would affect the way your hologram stands out from the background, how it's perceived. And when you're designing the system, try to make them as realistic as possible, but not so dull and pastel, because bright colors are the best colors for the AR applications at this point. And for sometimes it's good to use multiple colors to make your system similar. As a designer or as an art student, you may know a lot about colors, and always try to work them as a palette. Try to reference something natural, because this is, for example, a picture of the cloud, and someone extracted the colors using just this tip tool, where you can sort of pick them up and create a color palette. If you're working, for example, in this room and you want to create a color palette of this room, take a picture of this room, use this tip tool, extract the colors, and create the color palette that will match this room, and that will make it absolutely natural for this environment. Or go somewhere else where you will use that application at the end, or create something very universal and basic. The dark colors are about the attention. For example, if you go to the section with Flemish paintings in different museums, you will see this classical Flemish tradition of putting something bright in front of the black background. Because this difference in colors between something bright and dark makes something stand out. And that sort of gives the natural attention to this object, in this case an asparagus. But if you want to create your experience and you don't know how to guide the attention, try to think about the colors as well. Colors as the means for navigation. In terms of making them change and switch the colors from dark to light, or switch the colors within your color palette. Think about that. What is like your working color at the moment? And sort of think about how you can use that. Also, the shade of the background, as I mentioned before, really matters. So think about the post fact of how your application is going to be used on site, how they're going to stand out. This is just a basic perceptual illusion of how the same color circle is used against the different backgrounds, like really dark and really light. And even though this is like the same color in all 5 cases, we perceive it differently, and we give different meanings to this circle. We think that this is something dominant, or this is something not so important. So also think about the colors of your background as well. The last section of my first lecture is about storytelling. So storytelling generally comes from writers thousands of years ago. All the histories, all the stories, all the legends, all of them are stories. And sometimes people even, well, we communicate in stories. We return back from work at home and say, oh, listen, what happened to me? I met someone, or I had this class. And this constructs to a story. It's just a very basic example. But when we want to tell a story to someone, we want to make it really like convincing. We want to make it clear, outstanding, precise, or unprecise, depends on what you want to do. And usually people, when they make films or movies, they tend to storyboard. Storyboard is the collection of your shots of the images for your movie that you want to create, and you think in terms of this shots, in terms of these pictures, of this sequence, and you try to visualize this for yourself of how your story will look like at the end. I think all film students are using this, and it's pretty common for people working with photographs as well to create storyboards of the future products. But when we think about storyboarding and creating stories for AR, it's really hard to put like everything you think in 3D to the plain, really dull piece of paper and draw something. It's not so convincing, and maybe you want to show something in 3D but you don't know how. So it's all cluttered, and then the sense is lost. And for AR, we try to prototype and create stories in 3D. There were a number of ways of how can you prototype for augmented reality and create a storyboard. The simplest way is just to go to the 3D modeling application, Unity or Maya or Cinema 4D, and to create a story just using the prefabs, the presets, basically the 3D models of objects. You can download them for free from many of the royalty-free 3D libraries online. And you can use them to create some sort of scenario. You can use standard tools, prototyping tools inside even the Unity. I created that in Unity. And this is like a step-by-step application explaining what's going to happen with the lung examination, with that patient, how the user is going to interact with the menus that are positioned around the user, what are the steps. So if you look this direction, you will see that's like the first step, the second step, the third step, and it's one of the ways. Another way is to create a story is to use the prototyping materials. We will talk about that more in the second lecture of how to work with prototyping materials for storyboarding in AR. But this is just a simple and basic way because everyone has a computer. You can download 3D modeling app for free as a student and work with that. It's really quick and efficient, and that also time-saving sort of, because you can easily change something, delete something, and it's very adjustable in terms of the content. With the real prototyping, it's a bit hard. You need to plan ahead what you want to have, what you want to achieve, because you waste the physical material for that. But this is the simplest way, and you can mimic the 3D in this case. Always try to map your story in terms of the scenario. It's like when you're reading a book or watching a film, there is a standard or unstandard classical way of creating a story. You have the culmination of your storyboard, you have the solution, and everyone is like a happy end or something else. I love to think about this as this like castle, this maps, where you have the rooms in the castle. Since it's in 3D, it's really nice to think, okay, I will have my user in this room, and then I will experience, the user will experience something else in the different rooms with the different backgrounds. And if you also think about this in terms of the rooms and spaces, if you need, you can mimic these spaces and environments with augmented reality, because you can easily and simply create them using the holograms. And also, when you create story, try to think about the story from the numbers of your personalities. Think about this as the designer, art student, programmer, engineer, I don't know, doctor, or maybe someone for whom you're designing this application. So try to step into the shoes of others when you're designing this story. It really helps you to understand the person better. But the story creates itself only when you show it from the numbers of perspectives, from the number of angles. And also think about this as, I don't know, multiple users in multiple rooms trying to create one story, and use this as the map for your journey within the AR application. Also, when you think about the stories, all stories have their characters. They have I don't know, mythical characters, real characters, and it's really hard to find that level of the character that will work fine in augmented reality. You might have heard about the uncanny valley. It's sort of the classical dissemination of the between realism and empathical experience. For example, when you're as a child, you draw a dummy person. It's okay. It's just very abstract for us. And then we have the cartoons, then we have really nice cartoons, like super cartoons. The visual effects are just flourishing. The area is absolutely unimaginably great. But then you see like a movie that's really bad, and you don't understand why it's bad. It's like all these Chinese robots when they try to invent like super realistic human when it's not human, and then at the end we have a real person. But here's the gap when it falls down, and we don't, for some reason, we don't perceive that as natural. because this is like a rule. Try to find the balance between how real your character is going to be and how empathic you want the person feel to that character. So try not to fall down in this into this gap and think about your characters. If you're about to use the hologram, or you want to do the emotion capture of the person, and you want to like 3D scan that person, how that would look like. Is it okay? Is it natural? Or is it like really something very creepy? Don't use that. There was a suggestion a couple of years ago at Augmented World Expo from German designers that, oh, let's use like really unified holograms without any facial features, without any features at all, for the holograms, and how that would work with the multiple users. For example, you have the telecommunication scenario. 5 people in the room talking about the new bridge project that is going to be between, I don't know, Africa and Europe. And you have multiple roles. You have like super manager who is playing baseball, and you have a constructor, engineer, and you have someone else with the red hat. And in this case, people are presenting their roles and their identities based on the features that belong to them as professionally, but not personally, without any facial features. It's really natural. It looks okay for this type of scenarios when you want to solve the problem of communication, but not to solve the problem of representation of that person. So when you're thinking about how the person should look like, if you want to have one, think about the final role. What's the aim of that person in the scenario? Is it to recognize that person, like chat between families, like Skype in AR? You probably want to have like a real person. But if it's a communication between different students in the room, in different countries, and the main aim of this communication is the subject, like geography lesson, you don't want to have facial features at all. You want to focus on the subject, create like a planet or something else. In summary, AR is about new ways. It's about new ways of interacting. It's about new ways of working with the space that we lived in before. Don't try to, just for this week, don't try to reference anything that you know about technology, that you know about computers, mobile phones. Try to think about world you live in terms of surrounding environment, the 3D space around you, but not the 2D space on your screens and on your phones. And always think about what you want to achieve, because yesterday I asked to send around the Google form, and I asked about like your superpowers that you want to have, what you want to achieve and you dreamed of, and it's about empowering these needs as well, realistic needs, and those that would make sense for solving some problems or fulfilling some needs, but it's also the new ways of empowering users